Today we will be talking about how to rank the A and B values of a molecule or molecules together. First off, we have to explain what the A and B values are. The kinetic molecular theory assumes that gases will just bounce off walls and not stick to anything, but this is not true. So since that's not true, we have to make our formula to put in these corrections. A is the correction for intermolecular forces, which basically amounts to how much the molecule wants to stick or repulse from something. B is the correction for molecular size, which is how big the atom is. So, for trying to rank A's, the first thing you have to do is put your molecules in their Lewis structures. So, we have an example over here. We have N2, O2, and HCl. We're going to put these in their Lewis structures. So, we have N with 3 bars and a valence pair, or lone electrons. We have O with a double bond and 2 lone pairs on either side. And then we have HCl, a singular bond, and 3 lone pairs. So now that we have them in their Lewis structure, we are now looking for how symmetrical they are. Depending on how symmetrical or unsymmetrical they are, determines their order. The more unsymmetrical they are, the higher they're placed. So this one over here is really symmetrical. Same with this one. However, this one over here is not symmetrical at all, so we know that HCl is first. Then, when you have two molecules that look like they're both symmetrical, you base it off of how many lone pairs they have. Since this one has 2 lone pairs on either side, it is less symmetrical than this one. Always make sure to look for symmetrical before you look for lone pairs. So this is the right order for the amount of A values. With this one having the lowest A value, and this one having the highest A value. Next, we're going to be looking at B's. B, as we said before, is a correlation for molecular size. The first thing we want to look at for this one is how many elements there are in it. Basically, usually this decides how big the molecule is. The more it has, the higher it is. So this one has 1 C and 4 Cl, this one has 1 C and 4 H, and this one just has 1 C and 1 O. Since this one only has 2 atoms, while these both have 5, this one is automatically the smallest. Now if you have one that has the same amount of atoms in each one, you want to go off of the weight in the atomic mass. So since they both have 1 C, we can ignore the C's and look at their Cl and their H. Since they're both the same, the one with the higher atomic mass will be the one that's heavier. So if we look at H, which is hydrogen, we can see that it's only got an atomic mass of about 1. Whereas if we go to Cl, chlorine, we can see that has an atomic mass of about 35. This means that having 4 Cl, this one is extremely more heavy than this one. So CH4 would go next, and CCl4 would go last. So this is them put in order from lowest B to highest B. Thank you for joining us today.